do. Today I'm going to give you a quick little lesson on helicopters and the process of how they fly. So first thing, you're probably wondering why do they even relate to you, or why does this matter? First off, there's quite a few reasons actually. Live flight, I don't know, live flight is always transferring from Utah hospital up to McKay-Dee. You probably see them a lot. All the fuel, electricity, water lines are generally built and maintained by helicopters. Also up here on Bountiful, there's a big trench that was built for water lines. You may have also seen the helicopters hauling up the pipes for that. Another big one, military, Forest Service, all those kind of things, police. Ogden has a few police helicopters as well. Unfortunately, I have seen a few episodes of The Bachelor, and they use helicopters every other scene, and that's pretty cool, and I wonder how much money they've spent on that. So filming, things like that, geographic surveys, map making. Biggest thing I'd like to touch on today is future career options, because that's sort of what I'm going into and really enjoy it. The biggest thing that got me interested in helicopters is the ability to access remote areas for like skiing and hunting and fishing. Looks like there's a typo. Anyways, so first off, the biggest misconception on helicopters is that the process in which they fly is a lot like this fan-powered skateboard. That's a big misconception. They do not fly as if it's a fan blowing up off the ground. It's just like an airplane. It has airfoils that create lift. Except for, compared to an airplane, it does not need forward motion. Here's the four basic characteristics of flight. Lift is what you're trying to create. Thrust is what's going to get you somewhere. Drag and weight or gravity. Drag is a product of thrust and lift. Weight is a constant, factor that every pilot's going to experience. This is a little bit of a diagram of an airfoil and how it creates actual lift. So here you can see the helicopter rotor blade. And if you look at this profile design, this is opposite than what's shown there. But you get the idea. So that's what's called an airfoil, and that's what creates lift. The first one up top isn't creating any lift at all. It's just running flat, the angle of attack is not there, there's no pitch. The blue lines represent air molecules running over the airfoil. As that airfoil starts to pitch or create an angle of attack, the molecules slow down as it runs over the top, whereas the lower ones keep their speed. Because of that, those lower molecules are going to want to lift up and equalize with those upper molecules, air molecules. And that's how pretty much the lift is created, is those molecules pushing up under the blade. And that's the same thing goes for airplane wings as well, but airplanes need to have a forward motion in order to get those molecules running over the airfoil. That lowest one shows you the bad reaction of what can happen. If you get too steep of a pitch or angle of attack, those molecules will disrupt over the passing edge of the blade. And therefore, it doesn't create lift anymore, and it's what's called stall. And very hard to recover from, and very dangerous for airplanes and helicopters. Basic parts of a helicopter are as followed here. Got this little guy, I don't know if you can see him. You got your main cabin, which is where you sit. You got your people, you got your controls. You got your rotor hub, you got your mast. These blades are what are creating the lift. Like on an airplane, these are the wings of the helicopter. You've got your tail rotor, which is compensating for the torque of the main rotor hub. We'll talk about that later, which is connected to the main cabin by the rotor drive shaft for the boom. And then you also have some type of landing gear, whether it's skid or wheels or pontoons for seagoing aircrafts. And then we have, first we're going to start talking about the
center button on there is a laser pointer also.
Oh, this. Cool. So we're going to talk about the main rotor system. Even the most simple rotor system is very complex. And there's three designs. There's rigid, semi-rigid, and fully articulated. This is a semi-rigid. This is like what I've flown. It's just two blades going off of here and there. Pivots over this main bearing, and the pitch is created by this bearing and these pitch links, which is created by the input sub-controls, which we'll also talk about. Here's a few more pictures of different types. This is a fully articulated. As you can see, there's no blade represented here or here. But this is a three-blade system, very complex. There's a lot of moving parts, bolts, bearings, things like that. This is a semi-rigid, four-bladed system. Looks very similar to the fully articulated, but there is actually no moving bearings. It's all done by flex of different materials and composites and elastomers. So like this is a big elastomer that allows for a flapping effect and also feathering. So now that we're actually in flight hovering with that lift created, how the actual helicopter moves is, this is in hover, this is representing hovering, which your rotor disc is the theoretical disc of when the rotors are spinning, is completely flat. In order to move forward, you have to tilt that disc forward, which is done by, again, the controls, which we'll go over in a second. Aft is by tilting it backwards, and then you can also see how you go side to side. Tail rotors, which compensate for the torque created by the spinning rotor blades, because they're spinning at about 3,200 RPMs per minute, which may not mean anything, but it just means they're going really, really fast. So the rotors spin this way, torque is created that way. You have to have some kind of system to keep your helicopter from just spinning. I don't know if any of you have ever played with little cheap remote controlled helicopter, but if the trim's not set up, the body of the helicopter just spins. And that's actually exactly what will happen with a real life helicopter if you lose your tail rotor or in some kind of accident or something like that. So here we have, so this last picture, that's just a basic standard style four-bladed tail rotor. This is a newer style called a fenestron, which you don't see them, the blades are spinning at this moment, but there's about 20 blades all encased in a body, so it's very quiet, very safe. You don't have the potential of walking by this behind the helicopter when it's spinning. So that's a pretty cool system. Also a few other systems to eliminate a rear tail rotor. This is a coaxial main rotor, which this top one spins one way, this spins the opposite, the lower blades, and that just eliminates the torque right there. This is actually a very interesting system called a no-tar system, meaning no tail rotor, and pretty much they have a fan and a motor that